Alrighty, this is video notes for section 10.3. We'll be talking about another type of special right triangle called a 30, 60, 90 triangle. And a 30, 60, 90 triangle. Of course, we have our 90-degree angle, and our other two angles are 60 degrees and 30 degrees. And just like in a 45, 45, 90 triangle, and we can start with a standard triangle, and we have a ratio that will always be the same for the lengths of the sides. So if you look at the triangle theorem for 30, 60, 90 triangles to the right, you can see in the standard 30, 60, 90 triangle, the side length across from 30 degrees is 1. The side length across from 60 degrees is the square root of 3. And the side length across from 90 degrees, or on our hypotenuse, is 2. We can use these ratios by setting up similar 30, 60, 90 triangles to solve for the side lengths of any 30, 60, 90 triangle. So look at example number 1. We're given a triangle, and we're given one length of that triangle. It asks us to find the length of the hypotenuse and the longer side. The longer side is always across from the 60-degree angle. So in order to do that, we are going to set up a ratio of our new triangle compared to the standard 30, 60, 90 triangle. So make sure you can see that standard triangle, and we're going to compare that to our new one. So let's start with what we are given here, which is the side length of 12. We have that this angle here is 60, so we know the missing angle must be our 30-degree angle. So 12 is across from the 30-degree angle. So let's compare the side lengths across from the 30-degree angle for our new triangle, which is 12. And our standard triangle across from the 30 is 1. So now we have one ratio. Okay, let's look now at the ratios of the side lengths across from the 60-degree angles. Well, across from the 60-degree angles in our new triangle, we don't know that. We're trying to find it. Let's call it x. So we're going to name that x. And for our standard triangle, across from the 60 degrees was root 3. So I'm going to put a root 3 in here. So we can use this information now to solve for x. We have two ratios, two fractions that have to be equal to each other because these are similar triangles. So in order to solve for x, we just need to cross multiply. 12 times root 3 is 12 root 3. We can leave this in radical form. And 1 times x is x. So x, or the length of our longer side, is 12 root 3. Now we also need to find the hypotenuse of our new triangle. We don't know what that is, so I'm going to call it h. And the hypotenuse in our standard triangle was 2. So we have a ratio of h to 2, or h over 2. But again, I can compare this to the ratio I had for the length across from the 30-degree angle, 12 over 1. And cross multiply to solve for h. So h times 1 gives me h. 12 times 2 gives me 24. So our hypotenuse has to have a length of 24. Alright, let's look at example number 2. In example 2, it asks us to find the length of the longer side and the hypotenuse once again. So we're going to set up our ratios of the new triangle that we have to our standard triangle. Alright, so in our new triangle, let's look first at what's across from the 60 degrees, which we don't know, so let's call that x. So across from the 60-degree angles, we have in our new triangle x, and in our standard triangle, if you need a reference back up, across from the 60 was square root of 3. Okay. Across from the 30-degree angle, we have in our new triangle a length of 5, and in our old triangle a length of 1. And in our hypotenuse, in our new triangle we don't know what it is, so I'm going to call it h. And in our old triangle it was a length of 2. Now all three of these fractions must be equal to each other because since these are both 30, 60, 90 triangles, they have to be similar. So I can go ahead and cross multiply to solve for both x and h. So to find x, I'm going to multiply x times 1 gives me x, and 5 times root 3 gives me 5 root 3. So x equals 5 times the square root of 3. I can leave my answer in radical form just like this. And to solve for h, again I'm going to multiply 5 over 1 and h over 2, cross multiply here. So 5 times 2 gives me 10, and h times 1 gives me h. So our hypotenuse has to be equal to 10. So we found both of our missing sides. Let's look at example number 3. Example 3, it asks us to find the length of the shorter and longer sides, but it gives us the hypotenuse. So let's make our ratio again of new to standard. And I'm going to draw my 30, 60, 90 triangle to the right here so I can remember what my side lengths are. And I'm going to draw it in a similar way to the triangle I'm given here. So remember, across from the 30, we have a side length of 1, across from the 60, a side length of root 3, and opposite the 90, a side length of 2. So let's set up our ratios. If we set up the ratio of our hypotenuse in each one, our new hypotenuse is 8, and our old hypotenuse is 2, our standard hypotenuse is 2. Okay, let's look at these side lengths across or opposite from the 60 degrees. In our new triangle, we have a length of y, and in our standard triangle, we have a length of square root of 3. And last, we looked at our third side. In our new triangle, across from the 30 degrees, we have an x that we have to solve for. And in our standard triangle, across from the 30 degrees is 1. So I have 3 ratios for our 3 sides that are all equal. I can cross multiply in order to solve. So first, I'm going to solve for y by cross multiplying 8 over 2 and y over root 3. So 8 times root 3 gives me 8 square root of 3. And y times 2 gives me 2y. In order to solve for y, I want y by itself, so I'm going to divide both sides by 2. And I'm going to get 8 over 2 is 4, so I'm going to have 4 root 3 is equal to y. Alright, I've solved for y, so now I need to solve for x. Now I don't want to compare x to this side, or the ratio that has a y in it. I want to compare it to the ratio that has only numbers, so I'm going to rewrite it to the side. So I have 8 over 2 is equal to x over 1. When I cross multiply, I get 8 times 1 gives me 8. X times 2 gives me 2x. So to solve for x, again, I have to divide both sides by 2, and I get that x is equal to 4. So in any of these examples, you just need to set up your ratios. You can always set up 3 ratios. Make sure the new side length is always on top, and the standard side length is on bottom. Cross multiply and solve for the variable. Alright, so you are responsible for checkpoints number 1 through 4.